Hi everyone, hope you've all had a good weekend. So just a thing to start with, I've had a few people emailing last week to say that the work's taken them longer than it should be and that kind of thing, or that it's a bit tough. So if you are finding it challenging, do email me to ask questions. I think it's great if you do that because it means I can see how people are getting on. If you don't email me to ask, I kind of assume that you're getting it. If that's not the case, then we'll be moving on and you'll be falling behind. So make sure you do email if you have questions. Another thing is that a lot of people have been saying the work's been taking them longer than it should be, so longer than 50 minutes ish, which is what a normal maths lesson would be. That is because when I'm setting the work out, I'm setting it with all the work I would have prepared for a normal lesson. So that does include the extension work as well, which quite often no one gets onto. So if it is taking you more than 50 minutes, do cut it off early because you shouldn't be spending more time than you would be normally in school anyway. If you feel like you want to carry on, if you're sort of getting the hang of it, you're feeling quite confident with it and you want to carry on, obviously I'm not stopping you. But if it is taking you like 2 hours to do an exercise, that's too long. If it's taking away from you at the time, if it's causing you extra stress, just call it a day when you reach about the 50-minute mark. Don't spend your whole day doing maths that you're hating. But do email if you do have questions. So that's just the first thing. So we're moving on today to look at non-linear graphs. So we spent the past few lessons looking at straight line graphs. As I'm sure you can guess by the title, non-linear graphs are graphs that aren't a straight line. So there's a couple of sort of key graphs we're going to look at. So this is linear. I'm including this as an example one as just types of graph in general, but this is obviously linear, so it doesn't fall into the category of non-linear. So these ones are ones we've seen before, quadratic graphs. So they'll have like a distinctive either a U shape or like an upside down U shape. So you will have come across these in lessons before, but maybe not spent that long on them. So cubics. This is one that we may not have seen. So this is rather than quadratics have it's sort of x squared plus something. So it's like y equals x squared plus 1, we'll say. So it's basically that the x in the line equation, the highest power it has is a 2. So it couldn't have any like x to the power of 3, x to the power of 4. As long as the highest power that x has is 2, it's going to be a quadratic one. Cubics, on the other hand, that is cubic. So the highest power of x is 3. So it's x cubed. So this is a graph of y equals x cubed. So it's got this kind of distinct, it's a bit like a quadratic here, but then it kind of goes down on that side. So it's a little bit similar, but it goes sort of down on the left hand side rather than going up on both sides. So this is one you'll need to kind of recognise the shape of, but you don't really need to be able to do much with it. You need to be able to draw one, but we'll see how we do that later in the lesson. And the last one is a reciprocal graph. So this is one where you've got y equals something over x, so we'll say 1 over x. So it's basically just some number divided by x. And that has this kind of weird shape where when it's coming near an axis, it keeps going. So this one will go way, way down, and it'll go way, way up. So the closer you get to the y-axis, the closer it gets to infinity up here and down here. Now on these axes, so again along the x-axis, as x gets bigger and bigger, it gets closer and closer to the axis, but it never crosses the axis, it just gets very, very close. And same over here as well. As you go back this way, it gets closer and closer to the axis, but it never actually touches it. Okay, so we're going to look at how we sketch graphs today. So I'm sure some of you are quite confident with this, and on the sheet, this is probably one that it would be ideal if you do have a printer at home to print it. If not, you do have squares in your books, you can just draw grid lines fairly quickly. So if you don't have a printer at home, draw the graph axes in your book and the table. So with this one, we're going to sketch the graph y equals x squared plus 4. So with quadratics and cubics, there's where we are at the moment in year 9, all we need to be able to do is draw these from a table. So the way to do this, it's given us a range, it's saying do it from x is minus 3 to x is 3. So we're going to pick sensible ones to do it, so we'll just do it every whole number. So we draw a table that looks like this. So we've got x is minus 3, so that's from here. We've got x is 3, going all the way to here, and we've done it once every whole number, so minus 3, minus 2, minus 1, 0, 1, 2, 3. And what we're going to do now is go through and work out the y values for this. So to work out the y value, we're going to just substitute in to this up here. So for this first one, we've got y equals x squared plus 4. So we're working out y, so we leave that. So we've got y equals. So x is minus 3. So we've got minus 3 squared plus 4. So careful when you do minus 3 squared, because it is minus 3 times minus 3, which is plus 9. So we've got 9 plus 4. So we end up with y equals 13. So that is, oh, it's already put in the table, so we've got y equals 13 there. So this next one, same idea, y equals x squared plus 4, except now x is minus 2. So we've got y equals minus 2 squared plus 4. So we have y equals, again, minus times a minus gives a plus, so we've got 4 plus 4, y equals 8. Okay, so keep going and we fill in this whole table, so it's quite samey, it's just doing a substitution. Basically each time where you've got the x squared, you're just putting in the new x value. So I'll do one more and then I'll just skip through the rest. So y equals x squared plus 4. So we've got x is minus 1. So minus 1 squared plus 4. And so minus 1 times minus 1 is plus 1. So we've got 1 plus 4, y equals 5. Okay, so we go through and we do this for all of the x values in the table. And so we've got our answers, we've worked out the y values. So what we've actually got now, these tell us coordinates. So we've got an x coordinate and a y coordinate. So when x is minus 3, the y value is 13. So when x is minus 3, the y value is 13. So we go up all the way up to here. So we've got our first plotted point. And we go through and we plot points for each of these. Oh, sorry, I didn't get high enough there. Should be one square up. So we've got our plotted points, and we can see this definitely doesn't form a straight line, which makes sense because this is a quadratic, because it's got x squared, so it's power of 2, so it's a quadratic. So what we do, we don't join these up with a straight line, because quadratics are curved lines, we plot it with a curve. So we try and draw a smooth line that goes through all of these. So we join with a smooth curve, and it should look like that. So don't worry if it's not exact, it should just be approximately a smooth curve. It should go through all the points if you can get it to. And that's it, that's all we need to be able to do. To sketch quadratic, we just need to fill in a table and then draw the curve that goes through all of them. So one thing to notice is when we did the quadratic before, it had a shape like this. You can see it's kind of a U-shaped graph. That is because with our x squared, it's a positive number in front of the x squared. So this is x squared, so that is the same as 1x squared. You will get quadratics that look a little bit different if you've got a negative in front of it. So you'll notice if you have a negative in front of your x squared, it flips the graph. So rather than being like that, it's more like this. So it just flips it upside down. So if you had a negative in front of your x squared, your graph's going to be the other way up. So something to be aware of. If you do plot a quadratic and it comes out looking like an upside down U, not necessarily made a mistake, it'll just be that you've got a negative coefficient of x squared. So at a glance you can tell immediately whether the coefficient is positive or negative by whether it's an upside down U or whether it's a correct way up U. Okay, cubic graphs. I'm going to go through this one, although the method is identical to what we did before. So again, we're doing it from x is minus 3 to x is 3, and we're given an equation here. We've got a cubic, we can tell because the highest power of x is 3. So the highest power of x is x cubed. So this is a cubic graph. So let's do this first one. So we've got x is minus 3, and we know y equals x cubed minus x plus 1. So careful, because we've got a negative here, and we can see that our x is negative, so we've got two negatives, we're going to have to be careful with that. Okay, so we've got minus 3 cubed, we've got minus 3, so that'll be plus 3, and plus 1. Okay, so minus 3 cubed, I'm just going to do that up here, so we've got minus 3 times minus 3 times minus 3. So if we do minus 3 times minus 3, so we'll do this first, we'll times them together first. So we've got plus 9, and then we've got times minus 3. So positive times negative gives negative, so we're going to have negative 27. So minus 3 cubed will be minus 27. And this up here is a good rule to remember. If you're cubing a negative number, your answer will be negative. So that's a little bit of a shortcut you can take rather than having to work it out each time. So we've got minus 27, and then we've got plus 3 plus 1, so that's plus 4. So altogether we've got minus 27 plus 4, so that is minus 23 as our answer. Okay, so I'm going to go through the next one as well. So if you're feeling happy you can do this, feel free to go and do it on your calculator. So minus 2, so we've got y equals x cubed minus x plus 1. Okay, so let's use our shortcut now for minus 2 cubed. So we've got minus 2 cubed, we've got minus 2, so that's plus 2 and plus 1. So to work out minus 2 cubed, that is minus 2 cubed. So it's going to be minus 2 times minus 2 times minus 2. So that will give us minus 8 overall plus 3. Because we've got plus 2 plus 1. So that will overall give us minus 5. So going through and doing the same substitution for all of the x values, we get one that looks like this. So with a cubic it's a little bit less obvious. We can see we've got 3 1s there, so let's plot those and see what we think is going to happen. So I've got one like that. So what we're going to do now is we join these with a smooth curve. So it looks like this. So you can see it goes up, it flattens out in the middle, and then it continues to go up. So this is a positive cubic shape. So on the next slide we'll just talk about that. So here again we can see, so this one over here, this is the positive cubic shape. So it starts going up, then it goes down, then it goes back up again. You can see over here, when you have a negative in front of the x cubed, like when we had a negative with quadratic, it flips it upside down. So now it goes down, up, down, whereas before it went up, down, up. So it does the opposite direction basically. So just something to be aware of. Basically look at the coefficient of whatever the highest power of x is. So if it's x cubed, you look what's in front of the x cubed. If it was a quadratic, then the highest power is x squared, you look what's in front of the x squared. That tells you which way up it's going to be. Okay, and reciprocal graphs, we'll do one of these as well. If you're feeling confident with, you know what you're doing with these, feel free to go onto the worksheet now. You don't need to watch me going through tables. I'm happy for you to skip on. Okay, so this one, bit of a bigger table. That is because we've got, it gets towards the y-axis, it gets a bit more, it changes a lot quicker basically. So we need to be able to see what it's doing a bit clearer. So that's why I've included a 0 here. Sorry, 0.5s as well here, and 1.5s, rather than just doing every whole number. You can see at 0 they've put infinity. So really it's undefined. There isn't a value at 0. So because it's 1 divided by 0, we can't do that. You can't divide by 0 in maths. So this one really is undefined. So when you're doing this, you don't actually, it doesn't hit the y-axis. On your diagram it should just go very close to the y-axis but not actually hit it. So with this one, I'm not going to go through and do the calculation because it's just the same each time. All you're doing is doing 1 divided by that. So this one will be minus a third, and then you'll go through, fill in all of these. So this is all rounded to 1 decimal place. So you can see it goes, in fact we'll just put the points on. So it's going like this. So you can see it kind of goes along, so starting on x is minus 3, goes along, and as it gets close to the y-axis it starts to increase, and you can see it's getting steeper and steeper, and then so at 0.5 it's at minus 2, it's going to keep going, so it'll keep going down like that, and then you can see it flips back up to the top, and then it comes down steeply, and then it flattens out again. So when you draw a smooth curve through that, it'll look like this. So you can see as well at 0 it doesn't actually hit the axis, it just goes close, and it goes close down here as well, but it doesn't actually cross the axis. So it's not a continuous line or reciprocal graph. Okay, so the task today, I've attached the worksheet to this one. I want you basically just to get through as much of it as you can in the time. So I'm aware that doing the substitution, plotting the graphs does take a while, so if you don't get through all of it, completely fine. I don't expect you to get through the full sheet. If you do, great. But if it does get towards the 50-minute mark, do cut it off early. Don't spend all day doing it, unless you want to. So yeah, that is everything. There's a website, Desmos, as well, which you can use to check your answers. I will go through the answers on these slides, so you can pause the video now, go have a look at that. As you're doing it, I will put up the correct answers on the slides, but I would probably recommend using Desmos, which is you just type in the equation, it draws it for you. So that's probably a bit easier to check because you'll be able to move the graphs around and have a look. So just one extra thing I forgot to mention, the question 6 onwards, the answers are right at the end of the video. So if you skip ahead to the end, if you're happy with the graphs on Desmos, just skip right to the end of the video to check your answers to question 6 onwards. So for question 1, you should have one that looks like this. So it's a positive quadratic, so it's a U shape, and it goes through the axis at 2. Question 2, you should have, again, it's a positive quadratic, so it's a U shape, and it goes through the axis at -1. Question 3, sorry about the diagram, this is just how neat I could get it from Desmos. X cubed, so it's much steeper, so it should go through at the origin, and then so go up, flat up. Question 4, so this one should go through the y-axis at 3, but again quite a lot steeper. It should be sort of starting, so I think we went from -3, so we're starting at -24 for your first point. So this one, reciprocal graph 3 over x, so I've plotted it here. It should look like this. Yeah, not much to say about it. Make sure it's not crossing the axis on your diagram because you'll lose a mark if it touches the axis. 2 over x, similar. Again, make sure it's not crossing the axes. It should be just getting close but not actually crossing. And here's the answers to the rest of the sheet. So yeah, check your answers, check how you're getting on. Email me if you have any questions or if it's taking you longer than you think it should be or you're not sure of anything.